Hi dear students, this is me Ishfaq, and today we are going to basically solve some of the numericals regarding the concept of vertical motion under gravity, because you know physics is incomplete without solving numericals. Having real life problems and solving them on board, this is the beauty of physics. But before solving some numericals regarding the motion, vertical motion under gravity, let me remind you the things which we have discussed so far regarding the concept of this vertical motion under gravity. We have discussed 5 equations of uniformly accelerated linear motion for a freely falling body as well. We have applied them to a freely falling body as well. Let me remind you those 5 equations for motion, rather the uniformly accelerated linear motion. If you remember those 5 equations, number 1 is V is equal to U plus AT. Okay. Number 2 is S is equal to UT plus 1 by 2 AT square. Number 3, V square minus U square, it is equal to 2AS. And for a uniformly accelerated linear motion, this average velocity is equal to U plus V divided by 2. And the distance covered in the nth second of the motion, it is basically given by ascent, that is equal to U plus A by 2, 2n minus 1. These are the 5 equations of uniformly accelerated linear motion, that is along a straight line. Now we have applied these equations, and you remember well, these equations can either be derived by the algebraic method or by the graphical method like we do in the 9th class chapter gravitation, or by the calculus method like we do in the 11th class, that is by calculus method, by taking the help of differentiation and integration, right? Now we have already applied these 5 equations to vertical motion under gravity, that is for a freely falling body. What we do, we replace this A by G, that is the acceleration due to gravity, which we have discussed in detail, and we replace this S, that is the linear distance or displacement, by this H, that is the vertical height. But my dear students, while applying these equations, we have to take care of the sign conventions. मैंने आपको sign conventions भी पहले ही बताई. G is taken positive when the motion is vertically downwards, because when the motion is vertically downwards, if you simply release a ball from the rest, the motion is being supported by the gravity. But once you throw a ball upwards, the motion is being opposed by the gravity. That is why we take G positive when the body is released from the top of a tower, for example, and we take G to be equal to negative when you simply throw a ball vertically upwards. Ultimately at the highest point it will come to the rest, and then it will start the downward journey. So while applying these equations, while solving some of the numericals regarding this motion, we have to take care of the proper sign conventions. Now you remember, G is taken positive for vertically downward motion, and G is taken negative for vertically upward motion. So these equations will become, when I replace A by G, S by H, so these equations for a freely falling body will become simply V is equal to U plus GT. Okay, S के बदले लिखूंगा H, it is equal to UT plus 1 by 2 GT square, right? Then this V square minus U square, it is equal to 2GS, average velocity as it is. This is U plus V divided by 2, and this S nth, or you can simply write H nth, this is equal to U plus G by 2, 2n minus 1. Now how to solve a particular problem in physics? For example, the question is, a ball is thrown vertically upwards with a velocity of 49 meter per second. We have to calculate the maximum height to which it rises, total time it takes to return to the surface of Earth. But before solving this very question, what we have to assume? In physics, we have to assume ourselves to be the observer, to be the experimenter. Imagine this is going in front of us, we are the observer, we are doing the things, and then try to simplify these equations. Like if I simply drop a body, this means the initial velocity is equal to 0. If the question reads like this, a body is released. What does this basically mean? Released means if the initial velocity is equal to 0, and if the question is like this, the body finally comes to rest, this indicates that the final velocity of the body is equal to 0. So if simply the initial velocity is equal to 0, if a body is just dropped from the top of a tower or just released from the rest from the hand, you have to take initial velocity to be equal to 0. Then these equations will be simplified. V will be equal to gt, h is equal to 1 by 2 gt square, and v square is equal to 2gs, or simply you can here write 2gh. Then the problem becomes a little bit simpler, right? So now let us apply these, and before solving some numericals, let me remind you the things which we have already discussed for a freely falling body. If you remember, I have already solved one numerical regarding the motion of a freely falling body. Like this, if you throw a body with a velocity of 15 meter per second, if I throw a body with a velocity of, for example, 15 meter per second, again it will hit the earth, it will hit the ground with the same velocity as I have already proved it. That is the velocity of throw. Velocity of throw, it is equal to the velocity of return. Number 2. Now once you throw the ball upwards, it will cover some maximum height, and then ultimately it will reach to the ground, right? Now once it reaches the top, at this very topmost point, its velocity will be equal to 0, and then it will start the downward journey. Now obviously it will take some time. Let t1 be the time taken by the ball from ground to the highest point. This is what is called the time of ascent. Now suppose t2 be the time taken by the ball from the topmost point to the ground. This is called time of fall, or you can simply call it time of descent. I have already proved it that this t1 is always equal to t2, that is time of rise is equal to time of fall, that is time of ascent is equal to time of descent, right? Now if I ask you a question which we are going to solve a little bit later, if I ask you a question, a ball takes 6 seconds to return to the thrower. So what does this actually mean? It means it has taken 3 seconds to reach to the highest point, then its velocity becomes 0, and then it starts the downward journey. Again it reaches the ground in the 6 seconds. So keeping these things, keeping these facts in mind, we are now in a condition to solve few numericals regarding the vertical motion under gravity. Let me read question number 1 for you. A ball is thrown vertically upwards with a velocity of 49 meter per second. Here when a ball is thrown vertically upwards, this means that the initial velocity of the body is 49 meter per second, right? Now what we have to calculate? Number 1, calculate the maximum height to which it rises. First of all, we should try to make a free body diagram. So let me make it here. Suppose this is the ground level. We are throwing the ball with a velocity of, for example, 49 meter per second. This is the velocity of the ball with which it was thrown. Now we have to calculate the height to which it rises. Number 1. Number 2, total time it takes to return to the surface of earth. I mean this time of ascent plus time of descent, right? We can easily solve it by using the equations of motion. First of all, we will have to calculate the height. Now if you remember this very equation, v square shabash minus u square, it is equal to 2gh for a freely falling body. Now we are supposed to calculate the maximum height to which it rises. Now you know when it reaches this very point, suppose this is point A, this is point B, hope you are following the steps. When it reaches the point B, what will be its final velocity at that very point? So at that very point, this final velocity will be equal to 0. So let me write it here, 0 square. Once again I will write u square, it is equal to 2h. Now since you are throwing the ball upwards, the motion is being opposed by the gravity. G के बदले positive लिखूंगा या negative. You have to take care of proper sign conventions. So I will write it minus g here because the ball is thrown vertically upwards. ठीक है ना? 0 square is 0. This is 0 square is 0, so I will write it here minus u square, it is equal to minus 2gh. Minus और minus cancel हो जाएगा. We have to calculate the maximum height to which it rises. So h will be simply given by u square by 2g. Now simple, you have to substitute the values now. u square के बदले क्या लिखूंगा? हाँ, initial velocity is 49. So this is 49 square divided by 2 into g. The value of g you know, this is 9.8. Now you can simplify it. This is 49 into 49 divided by 2 into 9.8, that is 19.6. If you do this very calculation, you will exactly get this is equal to 122.5 meter. Do this calculation yourself. Simply 49 into 49 divided by 19.6, that is exactly equal to 122.5 meter. This is the maximum height to which a ball rises when thrown with an initial velocity of 49 meter per second. Hope you are following the steps. Now the next part of this very question is we have to calculate the total time it takes to return to the surface of Earth. I mean the time of the entire journey. I mean the time during which it remained in the air. So first of all I will calculate this t1, that is equal to time of ascent. So time of descent will be same. So total time will be equal to t1 plus t2. कैसे calculate करेंगे? Simple relation है, अभी हमने discuss की. v is equal to u plus gt, है ना? Now at the highest point, what is the velocity at the highest point? It is equal to 0. ठीक है ना? Now the initial velocity of this very body is 49 meter per second plus, हाँ अब बताओ, since body is thrown vertically upwards, g के बदले लिखूंगा minus g into t. Okay, so this is 0 is equal to 49 minus gt. Are you getting this or not? g के बदले मैंने negative क्यों लिया? Because the motion is being opposed by the gravity. So simply gt is equal to 49, or I will write t, that is equal to 49 divided by g. So this is simply equal to 49, g के बदले लिखूंगा 9.8. Now simple, divide 49 by 9.8, you will exactly get t is equal to 5 seconds. So this is the time taken by the ball to reach the highest point. What will be the time taken by the ball from point B to point A? I mean during the downward journey, it will be again 5 seconds. So I will write, let t1 is equal to time of ascent, that is equal to 5 seconds. t2 will be again equal to 5 seconds, that will be equal to time of descent. And so time of flight basically equal to total time during which the body remains in the air, that is simply equal to time of ascent plus time of descent, that is simply equal to 5 plus 5, that is equal to 10 seconds. है ना simple? This is how we solve the problems in physics, how we make the free body diagram, and how we try to simplify a complex problem into simpler ones. Then it is quite easy to get the answer of this very question. Hope you followed, hope you enjoyed this very numerical. Now let us solve one more. So the next question regarding motion of a freely falling body under gravity. The next question will be, okay, a stone is released from the top of a tower of height 19.6 meter. I have a stone or simply a ball, it is released. What does this indicate? Yes, initial velocity is equal to 0. Now the height of the tower is 19.6 meter. We have to calculate the velocity with which it strikes the ground, because after it then it comes to rest, but we are basically here interested in the velocity, in calculating the velocity before it strikes the ground, with which it strikes the ground, right? So the question is, a stone is released from the top of a tower. Here suppose this is a tower of height 19.6 meter, ठीक है ना? Okay, calculate its final velocity just before touching the ground. Okay, now see, since the body is just released, what will be the initial velocity? Okay, it will be equal to 0, right? Now height is given, it is 19.6 meter. We have to calculate the final velocity with which it strikes the ground. As per the relation we know, v square minus u square it is equal to 2gh. Now, hope you have understood this. Since body is drawn vertically downwards, motion is being supported by the gravity, so we have to take g positive here. So v square, okay, minus u square के बदले लिखूंगा 0 square, it is equal to 2, okay, this is g, okay, so this is h. Let me write it as it is. 0 square is 0, so simply v is equal to, v square is basically equal to 2gh, so simply v is equal to under root of 2gh. Now simply I will substitute the values to calculate the final velocity with which it strikes the ground. So this is simply equal to 2, ठीक है ना, g के बदले क्या लिखेंगे 9.8. Now what is the height of this very tower? That is given, it is equal to 19.6 meter, right? Okay, now try to simplify it a little bit, you will get the answer of this very question. 2 into 9.8, if you multiply this, you will exactly get 19.6. So this is again 19.6. 19.6 into 19.6, that is 19.6 square. Square और root cancel हो जाएगा. So this is 19.6 square. Square और root cancel हो जाएगा. So this is simply 19.6. We are interested in calculating the final velocity, so the unit will be meter per second. So the ball or the stone, it will hit the earth, it will hit the ground with this very velocity, that is 19.6 meter. So easy question it was to solve. So this was question number 2 regarding vertical motion under gravity. Now let us solve one more question regarding this vertical motion under gravity. Question is, what will be the distance moved by a freely falling body from rest in the 5th second of its journey? You remember the difference between distance traveled in 5 seconds and distance traveled in 5th seconds. I have already cleared this. So here the question is, what will be the distance moved by a freely falling body from rest? Now once the body starts from rest, initial velocity is equal to 0. We have to calculate the distance traveled by a freely falling body in the 5th second of its motion. You can either call it s5th or h5th, distance traveled in the 5th second. If you remember the 5th equation of motion, this s(nth), it is equal to, याद है ना, it is equal to u. Here I will write u plus g by 2, 2n minus 1. Now since the body is released from the rest, so and we have to calculate, this is the distance traveled in nth second. So here n के बदले लिखूंगा मैं 5, because we have to calculate the distance traveled in the 5th second of its motion. So I will write s5th, that is the distance traveled by a freely falling body when released from the rest. G will be positive, so u के बदले लिखूंगा 0 plus this is equal to g by 2, this is equal to 2, n के बदले लिखूंगा 5 minus 1. So this is simply equal to g by 2, 2 5s are 10, 10 minus 1 is 9. So this is 2, 4s are 5s are. So this is 4.5 into 9.8, 4.5 into 9.8. If you do this very calculation, you will get the result approximately to be equal to 44.1, or this is 44.1 meter. So this is the distance. If you do this 4.5 into 9.8, right, this will be 44.1 meter. So this is the distance traveled by a freely falling body when released from the rest during the 5th second of its motion. So now let's try to solve one more numerical regarding the concept of vertical motion under gravity. So here we go with this very question. A stone is allowed to fall from the top of a tower 100 meter high. Here we have a tower that is 100 meter high. Suppose this is the height of the tower. So let's try to make first the free body diagram, and at the same time another stone is projected vertically upwards from the ground. This is a body that is released from the rest, and at the same time we are throwing a body vertically upwards from the ground with an initial velocity of 25 meter per second. Okay, calculate when and where the two bodies will meet. Where to calculate when? I mean the time. And where? Where means in between the two. I mean, suppose this is A, this is B, where they will meet. You can calculate the distance from the ground, or you can calculate the distance from the top of the tower as well. Now, the question basically is like this. Let me illustrate the question. The question basically is, we are basically dropping a body from the top of a 100-meter high tower. Remember this, we are simply releasing it. But at the same time, simultaneously, I mean, we are throwing this body up, ball up, with an initial velocity of 25 meter per second. We have to calculate the time after which they meet and where they will meet. Simple सा question है, मैं इसको solve करूँगा यहाँ पे. Simply, let me consider that the two bodies meet at this very point, I mean C. जब मैंने बॉल को ऊपर से रिलीज किया और यहाँ नीचे से साइमल्टेनियसली मैंने बॉल को थ्रो किया विद एन इनिशियल वेलोसिटी ऑफ 25 मीटर पर सेकंड, सो डेफिनेटली दे विल मीट समवेयर आफ्टर सम टाइम. मैंने अज्यूम किया लेट दे मीट एट पॉइंट सी. सपोज दिस डिस्टेंस इज इक्वल टू एक्स, आई मीन AC. व्हाट विल बी BC इक्वल? हाँ, this will be equal to 100 minus x. You are getting my point or not? Now let us discuss it in two parts. Part first, let me discuss the motion of this very body that is simply released from the rest. If you simply release the body from the rest, what will be the distance traveled? It is equal to S is equal to UT plus 1 by 2 GT square. Now, since the body is simply released from the rest, what is the distance traveled up to this very point C? It is equal to x. You are getting my point or not? Simple सा question है. मैं पहले इस बॉल की मोशन को डिस्क्राइब करूंगा, सिंपलीफाई करूंगा. Up to this very point, it covers a distance x. So as per this very relation, x is equal to u के बदले लिखूंगा 0 because the initial velocity is 0. So this is equal to 1 by 2 gt square. Now let me say, let me suppose t be the time, let t seconds be the time after which they meet. For example, it can be 4 seconds, 5 seconds or 6 seconds. So let t seconds be the time after which the two balls meet, right? So x is equal, this is equal to 1 by 2, g के बदले लिखूंगा 9.8, so this is t square. So 9.8 by 2, if you do this, this is 4.9 into 2 square. ये मैं लिखूंगा x के बदले. Remember this very relation. Now let us try to study the motion of a ball which is thrown with an initial velocity of 25 meter per second. Up to this point, I mean C, it covers a distance of 100 minus x. Again I will use this very relation, so I will write s के बदले क्या लिखूंगा अब 100 minus x. Very good. So this is given some initial velocity u, that is equal to 25 into t, ठीक है ना, plus 1 by 2 gt square. Okay, plus 1 by 2 gt square. ठीक है ना? Now see, I will write it. This is 100 minus x. This is equal to 25t. Now, as per the sign conventions, this body is thrown upwards. Motion is being opposed by the gravity, so g is negative. So I will write 1 by 2 gt square. ठीक है ना? Okay, so this is equal to 100 minus x. That is equal to 25 into t. g के बदले जब लिखूंगा 9.8 divided by 2, that is 4.9. 4.9 into t square. Okay, 4.9 into t square. So this is 100 minus x. It is equal to 25t minus. Now see, 4.9 t square. Here it is equal to x. So I will substitute its value. So this is equal to x. x और x cancel हो जाएगा. So 100 is equal to 25t. Simply t is equal to 100 by 25. 4s are simply. So t is equal to 4 seconds. So after 4 seconds, the two balls will meet. So 4 seconds, this will be the time after which the balls will meet. Now we are supposed to calculate when and where. When we have calculated, I mean time, where the two balls will meet. So we will calculate the distance. We have already made the free body diagram. So x will be basically equal to, now you can simply calculate it. You can simply calculate it from this very relation. Here it is x, it is 100 minus x. T we have calculated already. Let me write it here. So if I write this okay, T I have already calculated. You can calculate this very x here from this very relation. X के बदले लिखूंगा 4.9 t square. T square के बदले क्या लिखूंगा? This will be equal to 4 square. 4 square is 16. 16 into 4.9. If you do this, this will be approximately equal to 78. Let me see it from here. So this is exactly equal to 78.4 meter. But if you take g equal to 10, you will get x is approximately equal to 80 meter. So the two bodies will meet, the two balls will meet after 4 seconds and at a distance of 80 meter from the top of a tower, or you can say 100 minus x, 100 minus 80, that is 20 meter from the ground. This is how do we solve the numericals in physics and the applications of these equations of uniformly accelerated linear motion. You can take your textbook and try to solve as many questions as you can regarding the motion, rather vertical motion under gravity. So this is time to take leave from you all. We'll be meeting in the next lectures. Till then, goodbye.